Guys, I wanted to post something here regarding the review, the last question on the review. It was brought to my attention that there was massive confusion about this, so I do want to give you an opportunity to see this one done one more time. So what I'm doing here, we'll go through this problem here on the calculator. So this starts with a list of data, and so we're going to enter this data into our lists. So we're going to say stat, enter, and I'm just going to type in, I'll use list 1 and list 2 here because they're available. So we're going to do 1, 2, 3, 4, 5, 6, and 7. There. And over here we have 8. We have 8 point. I don't know why it does that. Why does it not let me use a decimal? 8.6. We have 9.6. We have 16.8. You got to make sure you enter these data values in correctly, or nothing will be right. Everything will be wrong if these data values go in wrong. So be careful as you're entering these in. We have 19, and finally we have 21.5. Those are taken right out of the review packet at problem number 21. Now this problem asks us to do two things. They want us to make what's called a logarithmic model, and a logistic model. So first off, what I want to do here, I want to graph these points just so you guys can see what they look like when I graph them. So we go to second y equals. We'll turn one of these plots on, and we'll tell it, hit enter there. We're doing a scatter plot. I just want to plot points. My x's are list 1, my y's are list 2. I can do a quick zoom 9 and I'll see my points. So the logarithmic model, if you remember logarithmic equations when we graph them, they kind of curve this way. So we're going to make a logarithmic model. The calculator will figure out the best fitting line for these points, or curve rather. No graph is going to go through all of these points, so the object is to get it as close as possible to all of them at the same time. So if we, from the main screen, second quit, I go to stat and I go over to calculate, I've got several different options here. I can do a linear regression, a quadratic, a cubic, quartic, another linear. I don't know why we list 2 of them on there, but here's the logarithmic one. This is a natural log, and that's the guy we want for a logarithmic model. So I select it, and I tell it my 2 lists. My x's are in list 1, separated by a comma. My y's are in list 2. Hit enter. It will find an equation that is the best fitting line for this data. So what we're going to do here, let's see if I have this down. Yeah, the model, that's going to disappear for a moment here when I write this down. My model, logarithmic model, is y equals, the a value, if you look at your calculator, you have 5.407, we'll call it, plus b times the natural log of x. Well, b is 7.419. That's going to be multiplied times the natural log of x. That is our logarithmic model. What I'd like to do is put that into y equals. Well, actually, we don't have to do this for the problem, but I'd like for you to understand this, just for your own understanding. If you ever want to look at a chart with this, you got to put it into y equals. So how do I get that equation into y equals without typing it in? You can type it in. That'll work fine. But if you want to paste it, go to y equals, and we'll press vars. You'll see number 5 is statistics. You want to go to number 5. And once you do that, you can go over to equation up here on top, and you'll find the regression equation there. So by selecting that, it pastes that equation into y equals. Now what's nice about that is now if we look back at our graph, you'll see this graph go, this is what it looks like when you superimpose it on top of our graph. Logarithmically, if we find any other logarithmic model, no other logarithmic equation is going to be as close on average to all these points at the same time. This is the best fitting one, called the least squares process. So a measurement that we can use to determine how good this model fits is the sum of squared errors. So I'd like to, this is something you'll have to do. So let's go through that process. Back in the lists, over on the end, the other day I showed you how to create a list called residual. We go up to the top, we go over, and you'll have a blank list, and hit enter there. I want to name that list second list. Residual should be there. If it's not, you go type in RESID using the green letters, and it'll work just fine. So here I'll use number 7. Enter, you'll see a bunch of values get put in there. What those values are, that's the vertical distance between the actual point and the predicted point from the curve. So you'll see some of them are negative, like this has a negative residual because the actual value is less than predicted, whereas this one has a positive residual. Well, if I add up the residuals, they're going to equal 0. So a fix for that, so I can still get some meaning out of this, I'm going to square those numbers. I'm going to put that in the list 6 over here. So list 6 is going to equal, I'm going to put the name, so I got to go to second stat, so I get into the list. There's residual number 7. I want to square those guys. So all the residuals have been squared. I'm going to add those up. Sum of list 6. So I'll do that from the main screen. Second stat. You'll find the sum over here in the math screen. It's number 5. So the sum of my list 6, let's call it 30.31. That is our sum of squared errors. We're going to compare that to what we get down here for the logistic model, and that'll help us determine which one fits better. You can't always tell by looking at the graphs. The smaller the sum of squared errors, the better the graph fits the points. So let's do the process over again, this time with a logistic model. So in our calculator, we're going to go to Stat, Calculate. This time, you go down to, here it is, there's logistic. Again, tell it list 1, list 2. That is a default. It will automatically use 1 and 2. But I like to have students do this because in the event you do use different lists, you're going to have to tell it so, and if you're not used to doing that, you'll forget. This one will take a moment because it's a bigger equation. I'm going to work with us here on my calculator. All right. So here's our model. We have this pretty confusing looking equation here, but you can see we have an A value of 4.3339. We have a B value of 0.4308 and a C value of 26.02. So we have to substitute those values in for here. So it's gonna disappear, so hopefully you're following along here. And let's write that model. So my model, my logarithmic model, and these are the graphs that grow and then they stabilize off like that. So anyways, it's C, which is 26.027, and that's divided by 1 plus A, oops, that's a plus sign there. 1 plus A, well A was 4.334 times E to the power of negative BX. Well, that would be negative 0.4308 X. Okay, so that's our logistic model. Now, just like before, we can figure out a sum of squared errors for this guy. Let's see how good it fits. Well, first off, I want to paste it in here. I want you to see what this graph looks like. Let's deactivate this one. Again, this is not part of the problem. This is just, I think, important to show. I'm going to paste it in here. Vars, statistics, equation, regression. Now let's graph that one. You see it starts to curve up and then it flattens out. Okay, not as drastically as what I showed you here, but it does that. So let's calculate the sum of squared errors. Back in the list, the residuals automatically changed when I redid the regression with the logistic. So these list 6 values are now no good. Actually, I'll leave them there. I'll go to a different list. So list 5 is going to be the square of the new residuals. And I'm going to add up list 5. You'll see those are different residuals now, right? Or different squares of the residuals that were before. So I'm going to add up list 5, and that'll be my sum of squared errors for this guy down here. So the sum, I can do second enter, and I'll just change list 6 to list 5. 11.94. Now that is a lower number. Since it's smaller, that means that the logistic model, we're going to use that, we're going to interpret that to say this is a better fit than the logarithmic model up there. And that's what number 21 was all about. Part C is using the sum of squared errors to determine which one's a better fit. I hope this helps. Again, I thought this was something you were very familiar with, and it turns out that you weren't. So hopefully you all get to check this and you follow through this and work through the problem, and it makes sense now. I'll be here in the morning. Come in if you're still having some issues.